Open standards are absolutely vital for creating interoperable agent ecosystems because they establish a common language and set of protocols that every developer can rely upon. By adhering to well-documented specifications, teams avoid the pitfalls of proprietary silos and ensure that agents built on one platform can seamlessly exchange messages, perform coordinated tasks, and share knowledge with agents on another. This not only prevents expensive vendor lock-in, but also accelerates innovation as developers can focus on improving agent intelligence rather than reinventing communication layers. The Foundation for Intelligent Physical Agents, FIPA, serves as a prime example. Its clear definitions for agent management, messaging formats, and directory services make it straightforward to integrate diverse agent toolkits. In my view, embracing such open frameworks cultivates a vibrant ecosystem where contributions are transparent, security vulnerabilities can be collectively identified and patched, and best practices evolve through community consensus. Ultimately, by championing open standards like FIPA, we foster a more flexible, resilient, and future-proof foundation for the next generation of intelligent agents. Open standards are the backbone of any collaborative agent ecosystem because they define a shared vocabulary and set of protocols that enable diverse agent development kits, ADKs, to interoperate without proprietary barriers. By adhering to community-driven specifications rather than closed vendor-specific implementations, developers can integrate modules for perception, decision-making, and communication with confidence that each component will exchange messages, data structures, and control signals in a predictable way. This prevents vendor lock-in so teams can swap or upgrade tools as requirements evolve, fostering healthy competition and accelerating innovation. Open standards also support complex distributed systems. When hundreds or thousands of agents must coordinate across cloud services, edge devices, or legacy platforms, a standardized agent communication language ensures reliable discovery, registration, and message routing under diverse network conditions. The Foundation for Intelligent Physical Agents, FIPA, exemplifies this approach by providing formal specifications for agent interaction protocols, ontology layers, and management frameworks, empowering teams to build robust multi-agent applications that can evolve organically, leverage community extensions, and maintain long-term compatibility without risking technical debt. Ensuring true agent compatibility demands a holistic approach that goes beyond mere syntax alignment. First, semantic consistency guarantees that when one agent requests start process, its counterpart interprets and executes the same workflow rather than treating it as a query or log entry. Interoperability then builds on this foundation, enabling agents to exchange information, invoke services, and negotiate tasks seamlessly, whether they originate from open source ADKs, proprietary platforms, or custom extensions. Portability is equally critical. By adhering to standardized serialization formats, lifecycle hooks, and dependency injection patterns, agents can be deployed or migrated between different runtime environments without rewriting core logic. This design ethos empowers organizations to experiment with evolving toolchains, cloud providers, or hardware accelerators without incurring prohibitive integration costs. Finally, long-term viability future-proofs the ecosystem by choosing community-governed specifications, versioning strategies, and backward-compatible extension mechanisms. Agents remain functional and maintainable as network protocols, security requirements, and deployment paradigms evolve. Prioritizing these interlocking dimensions creates resilient, adaptable multi-agent architectures that can scale, innovate, and endure in the face of technological change. Non-standard implementations fragment what should be an integrated network of intelligent agents, creating isolated silos where each bespoke system speaks its own language and follows its own rules. In practice, these silos become barriers to innovation. Teams investing in custom communication stacks must also build and maintain unique adapters or gateways just to enable minimal interaction with other agents. Proprietary protocols compound the problem as opaque message formats and hidden state machines make it nearly impossible to trace message flows, reproduce errors, or enforce consistent security policies. Debugging becomes a painstaking trial and error process rather than a straightforward examination of well-documented exchanges. Moreover, the total cost of ownership skyrockets when every upgrade, patch, or feature addition requires bespoke development work instead of leveraging community-driven libraries or plug-and-play modules. Organizations face lock-in not just with their vendors, but with their own in-house teams who hold the tribal knowledge needed to keep these custom solutions running. From an adoption standpoint, the lack of broad compatibility discourages external contributors, partners, and open source communities from engaging, slowing ecosystem growth and stifling collective advancement. In my opinion, sticking to established standards and protocols is the most effective way to reduce complexity, lower maintenance costs, and ensure a vibrant, cooperative, multi-agent ecosystem. Adhering to standards in agent development is not just a technical preference, but a cornerstone of ethical design. When agents use standardized communication protocols, every message carries a clear, well-documented intent, making it easier for developers, auditors, and end users to understand why an agent proposed a particular action. This transparency prevents hidden behaviors and minimizes the risk of unauthorized or malicious operations slipping through unnoticed. Accountability follows naturally. Standardized logging formats and interaction schemas enable precise tracing of decision paths. So if an agent makes an erroneous or harmful choice, its entire reasoning chain can be reconstructed and assessed. Moreover, common frameworks for data handling and decision models foster fairness. By relying on community-reviewed standards rather than ad hoc rule sets, agents are less likely to inherit biased logic or discriminate against certain user groups. In my view, embedding ethical considerations into the very protocols agents use ensures that as these systems grow in complexity and autonomy, they remain aligned with human values and societal norms rather than drifting into opaque or unfair behaviors. Identify and adopt relevant open standards tailored to your agent's domain, whether that be the Foundation for Intelligent Physical Agents, FIPA, specifications, Object Management Group, OMG, middleware guidelines, or emerging industry frameworks such as IEEE P243 for IoT interoperability. Begin by mapping your agent's core requirements, messaging, lifecycle management, security, and data modeling to the capabilities defined in these standards. Implement standardized communication protocols like the FIPA Agent Communication Language, ACL, to structure your performatives and ontologies, or leverage RESTful APIs that conform to widely accepted HTTP methods and media types for web-based integrations. Integrate schema definitions from OMG's Data Distribution Service, DDS, for real-time publish-subscribe architectures, ensuring reliable data exchange across distributed nodes. Next, establish a continuous compliance process. Automate conformance tests against protocol specifications. Validate message schemas with tools like XML schema definition, XSD, or JSON schema, and include interoperability testing with reference implementations. Document every design choice, from the rationale for selecting a specific standard version to custom extension points, so that future developers understand the context and trade-offs behind each decision. Maintain version control on your integration artifacts and update your documentation whenever standards evolve or new ballots are ratified. By aligning your architecture with proven, community-driven specifications and rigorously validating adherence, you create a resilient, interoperable ecosystem that can adapt to technological shifts, external audits, and collaborative innovation without incurring avoidable technical debt.